Alright, this is chapter 4, number 25. Here you see the man is being pushed by the ground forward. He's sprinting around. And he's sprinting around 100 meters. He goes the first 45 meters accelerating. We don't know what his acceleration is. We don't, well, we know his initial velocity was 0. He started from rest. And his final velocity we don't know. But we need to find that out. And the time it takes, we don't know either. We know he's 66 kilograms. We also know that it takes a total of 10 seconds to run around the track. So the next part of the race, he's running. He's running the fastest he can. And he stays at that speed for the next 55 meters. So that speed will be the final velocity that he reached in the first part of the race. The second part of the time will be the full amount of time, 10 seconds, minus the first part of the time. So 10 seconds minus t1. You could also look at this as this formula. This is the same thing as velocity equals distance over time, but I solved it for t. So time is distance over velocity. Okay. Generally, what we'd like to do is we'd like to find the time. We'd like to find the velocity, that final velocity. If we find all that, that will help us find the acceleration. If we had the velocity, we could find the acceleration. If we had the time, we could find the acceleration. So let's do that. First part, we can use this formula. The initial velocity plus the acceleration. I got interrupted by my cat there for a minute. That's okay. No damage done. Alright, so here's a formula we can use. And if we This is the first time I'm doing pause. Okay, so let's just keep this on the wraps for now, and let's look at another formula where x, it's really the change in x equals v initial plus 1/2 at squared. That's another formula we could use. In this case, this is good because the initial velocity is 0, so we're left with delta x equals 1/2 at squared. If we solve for a, we get a equals 2 delta x all over t squared. We could plug some numbers in. We know delta x for the first part of the trial is 45 meters. 45 times 2 is 90. Normally it's good practice to just keep everything in letter form. So 90 meters t squared. Alright. But this has a lot of parts, so I'm going to simplify it by putting the actual numbers in before. Now, if we take this and plug that into here, then what we get is, let's separate this, we get V final equals, V initial is 0, right? Right? I can't hear you. Oh, that's right. You're not here. Okay. 90 meters divided by T1 for 2 and 2 for T. Okay. And then, so that's acceleration times time. Look what happens. Yes, indeedy. One of those cancels. So we get 90 meters over T1. And that is the final velocity. Sweet. We'll continue with more in just a moment.